when I'm teaching people math, it's scary to talk about a lot of numbers. So I've just come up with a simple way to describe this. Just think of it as a key. It's sort of the key to the code that they're using to control the election. So this is like an introduction for that. And this slide is a fun slide for me to start with, because if you notice the date timestamp on this, it's September of 2020. And this is before I even began looking into the election in terms of corruption. So this is one of those divine accidents, one of those divine appointments. I was teaching. I teach at a special school here near Cincinnati for really bright youngsters. And I don't like teaching these children their calculus or their differential equations by just using the book. I like to use the book, but then simultaneously, I like to teach them another real life example that we can apply the math we're learning immediately to. So I was using, guess what? The 2020 census. I'm sorry, let me retract that. The 2010 census, and you can just download this right from the internet, which is what this graph is. Now, what I did is I downloaded 8 years worth of it. And this is right off, I'm not making this up, this is just downloaded data. And just to kind of help you understand what this is, across the bottom you've got age, 0 to 100 years old. And then on the y-axis, this is how many millions of people are of each age. So you notice there are about 4 million people born each year. And then as you increase in age, you notice, well, here are the millennials, there's a peak of millennials, and then here are the baby boomers, and then people begin to pass away. And you notice that each year, the graph just kind of shifts 1 year over at a time. You notice the back curve, the blue curve, that's back in 2010. And then this most front curve, the kind of brownish orange red one, that's from 2017. So you notice that it just kind of marches along year by year, but you notice that the detail doesn't change much. And that's because the US Census doesn't do the detail every year. They only do the real serious detail every 10 years. And everybody knows we just completed the 2020 census. So that they do is they take the 2010 census in great detail, and then they just kind of bump it 1 year every year, and they estimate how it changes a little bit. So a lot of times people are confused by my work. They think that I'm using the 2010 census. I'm not, but the shape of the 2010 census, certainly, yes, that I'm definitely using that, because that's what shifts along year by year. So anyway, that's sort of a fun thing. It's a divine appointment. And I'll tell you, if I hadn't been teaching my students this at the beginning, and I probably wouldn't have recognized the clue that helped me figure out what was going on in the election. So that's a fun graph to start with. All right, so, but you don't have to just look at the whole United States. You can also look at county by county. And here's the county I first started with, because this is where I was asked to look at the election to see if I could figure out the fraud that had taken place or if there had been no fraud. And it's Pennsylvania District 4. It's mostly Montgomery County in Pennsylvania. And you notice it's, once again, we've got across the bottom the age, 0 to 100. And then we got how many population of each age. And here we got 8,000 people that are just born. And you can see year by year. And it's a total population of about 730,000 people. But of course, they all can't vote. So if we take out the 0 to 17-year-olds, and then we also take out a few percent, because not everybody can vote. Some people they live there, but they're foreigners and they're here on a visa legally, or sometimes there are people that are convicted felons that are not allowed to vote. So let me just kind of flip between those two so you can see what I'm doing. I'm basically saying, sorry, I clicked the wrong way. Here you go. This is the population of, and this is, by the way, based upon the 2019 census now. So this isn't 2010, this is 2019, best data they have available for us. And then if you take out the 4% and you remove the 0 to 17, this is who's eligible to vote in Pennsylvania District 4. And here's the first anomaly that tells you something is up. Here's who's registered to vote in Pennsylvania District 4. And every time I show these graphs to county clerks, boards of election people, their jaw drops. They don't realize this has happened to them, that their registration rolls have been inflated. They didn't know this had happened. So this is the first big thing, the first red flag. 98% of the possible population is already registered. So that's a big warning signal.
Yeah, that doesn't happen. No, this is the first
No.
doesn't happen. There's a number.
No.
Like over in the
Everybody
70 and 80-year-old category, you got more people
Yes.
voting than what we got people.
Exactly. So that's like the first red flag, right? That's the first, danger, Will Robinson. Something's wrong with your election. You've got too many people registered. This is not realistic. So that's an important thing to realize. Now here, this graph, this red graph, shows you by age everyone we got a ballot from. So when you look at that, you notice some things. You look at this and you say, well, wait a minute, that red curve looks an awful lot like that black curve. Surprisingly so. So that's another warning sign. And you might say, well, yeah, but how come nobody's noticed this before? And the answer is because people that manage elections are not number guys like me. They use programs that are provided to them by the companies that make the election software, and they don't graph it this way. So like nobody's noticed this before. Maybe the people who have noticed, maybe who are the people who are manipulating the election. But for when I show these data to election people, their jaw drops. And by the way, let me say that again. These are data. None of this is made up by me. These are just straight right from the census, right from the registration databases. So this is me just showing you what the facts are.
That people understand. So that black line is showing irregularities where there are more people supposedly registered to vote than there are voters. And this red line of the ballots received mirrors it nearly perfectly, which that black line was an anomaly, so that red line has to be an anomaly.
Yes, well stated. That's a good way to look at it. And I can help you to see that by, if I take that black line and multiply it by 13/15, or about 86%, you notice that above about 50 years old, everything's like a perfect match. I mean, it's just it's ridiculously close. That's a warning flag, right? Now, you might be able to say, okay, well, what an amazing coincidence. Except I'm about to show you that it's not a coincidence, and I can predict every county, and I shouldn't be able to do that. So that's some of the proof that I'm about to show you, or help you to understand. There's a number, it's called the correlation coefficient, R. And R, if R equals 1.000, that's a perfect correlation. That means one set of data predicts another perfectly. And 0.994, that's ridiculously close to 1.00. Most social scientists that do social science work dealing with people, if they get a correlation coefficient R equal to 0.7, that's really good. If you're doing medical research and you're studying the effectiveness of a drug, if you get 0.6 to 0.7, you're doing great. That's a very powerful drug. Anytime you deal with people, the correlation coefficients tend to be low. So to get 0.994, that's just not natural. As a physicist, I was joking with Mr. Lindell. I said, that ain't natural, buddy. That's just not natural. Now you notice it doesn't fit perfectly everywhere, but the little bumps and wiggles are still all there. I'm just showing you data here. You notice I haven't done anything. I'm just showing you data only. And that's important to realize. Now I mentioned the 2010 census. So let's start again with the 2010 census. This is the 2010 census, downloaded right from the government. You notice the date of this, because this was when I was preparing a formal report for the Pennsylvania legislature at that time. I'd already done the work about a month earlier. But so here I am preparing it late January, and you notice it's got all these bumps and wiggles in it. And this is from 2010. Now, of course, this is 10 years ago. And also, I'm interested in comparing this to the Pennsylvania District 4. So I've also multiplied it by a very small fraction. So that way, this 8,000 number, instead of it being 4 million, it's only 8,000. So I've shrunk the curve. I've made it smaller. Now, if I shift it to the right, because it's 10 years later, so you notice I've shifted this curve to the right. And then, of course, when you shift it to the right, 90-year-olds don't just become 100-year-olds. Some of them pass away. So if I just show that again, you start from the census, you shift it to the right, you include the mortality. I'll just flip back a couple of times so people can see that. So I'm shifting it to the right, including some mortality. That's what we would expect the 2010 census to look like today in 2020? Well, if we add that black curve from before, the registrations, this is what we get. It's very close fit. So this was the clue that said to me, there's something going on with the census. And I would not have even noticed this if I hadn't been teaching it to my students in September. But there's this peak here and these two peaks on the side, and they jump right out at you. And I remember when I was first studying these data here, and I was looking at it, I was just like, I recognize this. I've seen this somewhere before. Where have I seen this? Where have I seen this? I wouldn't even gone down this road looking if I hadn't recognized that. So I think that's another one of those divine appointments. That God prepared me for this moment. So that gives you an idea what that's like. And that's not a perfect fit, but that's just the clue that shows you that a perfect fit is possible, and that an algorithm is operating. And I just remind you what this graph looks like. You can see that the registrations are in there. And so I like to tell people that the algorithm uses the 2010 census, shifted and normalized, which means make it the same size as the population. And you know that because you can see the features of the 2010 census in it. But the algorithm uses the census to know how much they can inflate the registration rolls, because you don't want to go past that, because if you're going to add 1 million 60-year-olds, that would stand out.
Yeah.
So computers are stupid. You have to know how many you can add, and that's what's added. Go ahead.
So you've been showing Pennsylvania. Is this something that's across the whole U.S.? Have you seen it in other places?
Yeah. In fact, when I was showing these data originally to the Pennsylvania State Legislature, they said, "Well, gee, have you done any other counties?" Well, no, I hadn't. I'd only done Pennsylvania District 4. So I started doing other counties, and suddenly that's when I realized, wait a minute. It's not the only one. In fact, they had the same anomaly and the same percentages. And so I was like, oh, wow, this is, and then I showed that to them and they said, well, have you done any other states? So I started doing other states. I'm almost to 20 states now, and I can predict, I'll show you here in a second. One of the next states I did was Ohio. And when I did Ohio, let me jump ahead to that. Let me jump ahead to Ohio here. Yes. When I did Ohio, I was expecting to not find this sort of behavior because Ohio, Trump won by officially 8%, and we have pretty good controls here, but no, it's everywhere. Let me just I can show you. Here's another county. Here's Hamilton County, Ohio. That's near Cincinnati. And once again, I'm starting with the census population. This isn't me making anything up. This is right from the 2019 census, because that was the most current census at the time. And then this is who's registered in Hamilton County. Does this look familiar?
Yeah. You see those same peaks.
1, 2, 3, there they are, exactly. Same as in the other.
Nearly 100% registration across the board.
There you go.
Which is unheard
and
of.
by the way, I've done thousands of counties now, and it's the same pattern over and over again. And here's who's turned in ballots in Hamilton County. Does this look familiar? Do you see the same kind of relationship? And here I am multiplying it by 13/15ths.
Well, I'm not a college graduate. I told you that I'm a dropout. But I did major in math, and one of the things I took was statistics. And the chances of something like that happening in every single county across the United States is absolutely impossible.
And when I look how many things happened to create this situation, how many things needed to be a certain way, it's a lot. And that's also other part of this is that if you would think what creating these circumstances, what it would have needed to somebody to plan it. It's just too many things to anyone to be able to plan that. But this is a conspiracy of coincidences. This is a perfect storm. Many things had to happen so that you have this phenomenon. Perfect storm. Perfect storm. Perfect storm. Perfect storm. Perfect storm.